Welcome to Data Science 1, Probability, Continuous Distributions. All right, so some things we need to go back and remember. We need to remember what a sample space is and what a random variable is. We've been changing gears here, so we have to go all the way back to the beginning, sort of. All right, so let's go back to our fishing example. Suppose we're going fishing, and I want to look at the sample space of catching just one fish. Well, let's see. I could catch a small fish that weighed 1.01 or 1.031 kilograms, or I could catch one that's a little bit bigger that weighs 3.234 kilograms, or I could get the mother lode here and get one that weighs 19.778 kilograms. Now, thinking of all the possibilities of the types of fish I could catch, there are just too many options to count, and that was what we were relying on in those previous distributions when we had discrete distributions, right? Because we could count the number of times we saw a specific outcome. Now, using a discrete distribution here is just not going to work because we can't count them up, especially when we try to think of all the ways we could measure this fish, just one fish. We could measure its weight, we could measure its length, its width, we could measure its value, and that could change every day. Okay, so let's try to rethink probability, but not reinvent the wheel here, okay? Just think back and see what we could possibly use. So looking at individual measurements and trying to assess the probability, that's going to be virtually impossible. But we do have another idea that's been floating around that maybe we could use. What if we looked at the idea of the cumulative distribution function? We did it for the discrete distributions, and I talked about it briefly because I knew I was going to talk about it more here, and we'll keep talking about it as we go along. So instead of counting the number of fish with the exact weight that I have, what if we count the number of fish that I've seen that are smaller? Okay, so I could come up with the probability that the random variable that I have is less than a specific number x. So the fish that I've seen that are smaller than x over the total number of fish that I've seen, right? This idea here will work because I can count them up, right? And that's the whole idea. And notice, I've managed to turn this experiment into a Bernoulli outcome. So for those of you who haven't been watching these very long, I keep mentioning we keep going back to Bernoulli outcomes, and it keeps showing up. All right, so the CDF, cumulative distribution function. This is going to work. So let's look at a picture of one. And here's a picture of one. They're typically S-shaped. They always start down near 0 someplace or at 0, and they go up and plateau at 1, okay? And this kind of makes sense. As x increases, we expect the probability to increase. And these are monotonically increasing functions, meaning they're always increasing from the previous value. So just keep that in mind as we go along here. But this makes sense. The larger the fish or the x that I picked, the more likely that I've seen a fish that big before, right? Or that's smaller than that. So this is pretty easy to think about, and it works, right? Because I can count them. All right. So this x increases, the proportion of fish that are smaller will increase until we reach 100%, and that's where the 1 plateau is. Okay, so let's look at 3 continuous CDFs. And here we can see the shift in the curves, but this is not really easy to see what's happening. Okay, and if you remember when we looked at the distribution plots, we could say, oh, that's really concentrated over here, or this one's the most likely, or something like that. Here, you really can't dig this out of this plot, and there's a reason. Because these are CDFs, okay? They're not probabilities. What we were looking at before in those pictures were probabilities. And I didn't show you pictures of discrete CDFs, which I will show in another video, because they look like a staircase, and most people get confused when they see one. So I purposely didn't show that to you yet. Get you used to the smooth ones, and then we can go to the ones that are staircased. Okay, so how do we go from probability to a CDF? We simply added up the probabilities. We were adding them up and counting them. To go the other way, what's the difference? What's the difference or the opposite of adding? It's subtracting. So we could difference them, and that will get us where we want to go. However, in a continuous space, differencing is differentiating, and that comes from calculus. So strap on your calculus boots. Well, you don't really need to. We're going to try to avoid it as much as possible with without hiding from it. Okay, we're going to see it, but we're not going to necessarily use it consistently. And so those who don't know it can still get all the information they need, and those who do know it can get even more information. So we'll see you in the next video.